It's like I don't care about nothing, man. Yeah. Oh,
What's going on, guys? Coach Carr here. Now, what I'm going to be doing is showing you a lot of the notes we've already been taking in class. I was slacking a little bit on getting all the notes video-wise for you, but I've been doing it in class, in live and in person. So I want to make sure that just in case you ever missed a day, it's an easy way for you to get the notes. So that's what I'll be showing in these. So since I've already taken the notes with y'all in person, I'm just going to kind of show you what we did in class and go over it. I think that's the easiest way. So the first thing, standard deviation, is used to tell how far on the average any data point is from the mean. So if you have a bunch of data, how far on average is it going to be from the mean if it isn't already there? If you have a smaller standard deviation, it's going to be closer to the mean. If you have a larger standard deviation, it's going to be a little bit more widely spread out on average from the mean. The variance can be thought of as a kind of average. So the formula for like the variance would be the x minus the mean squared. So when we do standard deviation and variance, this will be important. And then we divide the quantity by n minus 1 rather than n. And hopefully now you know that n stands for the amount of numbers that we're plugging in. And then the z-score, or z-value, gives the number of standard deviations between the original measurement x and the mean u of the distribution. So a z-score, or z-value, is basically just an exact amount of standard deviations. So on page 2, I give you exactly all the steps that are needed in order to find the standard deviations. Now, what I did on page 3, I gave you an example and I kind of dumbed down the steps. So the first step was find the mean. So I added all these numbers up here together and divided by the amount of numbers there are. That gave me a mean of 6.4. The next step was subtract the numbers with the mean. So I went through each number. It does not matter if it's if you put it in order or not, because in the end you'll see that you're just going to be combining them anyway. So you subtract those numbers from the mean. It is okay to have negative numbers because some of them are going to be smaller than the mean. Step 3 is to square those numbers you just got. So by squaring all the numbers, you should have all positive values, because any negative number multiplied with itself will become positive. So all of your numbers should now be positive number. You're going to then add all those numbers together. So I added these numbers here and got 26.4. Then you take that number you just found and divide it by n minus 1. So I'm going to move this down slightly so you can see that. So what I did was there was a total of 10 values, so I had to subtract that by 1. So 26.4 divided by 9 gave me 2.93. This step 5, is to find variance. So this would be my variance. Now we have one last step to find a standard deviation, and we take that number and square root it. So when I square root it, I now have 1.7126. This was our standard deviation. So then the practice that I told you to do, which is for a grade, was then to do the practice on the next few pages, pages 4 through 6. So if you haven't sent those to me or shown them to me, make sure that you do that so you get that grade. The next thing that I went over in the notes was this 68, 95, 99.7 rule. This can also be called the empirical rule. So if you hear empirical rule, this is what it is. But the idea is about 68% of values fall within one standard deviation of the mean. 95% will fall within 2 standard deviations. And almost all the values, 99.7, fall within 3 standard deviations from the mean. So if I want if I say I don't need an exact number, or I want to know generally how much is going to be within a certain amount of standard deviations, you could use this rule as long as the data is normal. But everything we've done in this unit is dealing with a normal bell curve. So I just want to hit it home with the pictures that were in here. This is on page 8. So if you notice within one standard deviation, that's where the 68% is. So anything that falls in here, roughly about 68% of your data will fall in there. Now when it's 2 standard deviations like you see on the one below it, those ones, 95% of your data will be inside of that. Then on the next page, you have this right here where if it's within 3 standard deviations, you then have almost all your data, 99.7. So the only time it won't fit within standard deviations is when you have some outliers. So the 0.3% is dealing with our outliers that we could potentially have. So on page 10, I gave you some examples with the 68, 95, 99.7 rule. First things first is we drew a normal bell curve and figured out where each of the standard deviations are. They told us that the lifetimes of 10,000 watch batteries are normally distributed. The mean lifetime is 500 days. The standard deviation is 60 days. Sketch a normal curve that represents this distribution. Label the mean and 3 standard deviations. So if you notice, the mean has to be the middle. So I made the middle 500. So when I'm going to the right, it's getting bigger. So that means since it gave me a standard deviation of 60, I added 60 each standard deviation. So this one was 560, 620, 680. Now anything on the left is getting smaller, so I would be subtracting 60 each time. So this one was 440, 380, 320. So the first one that we did together was part A. It says how many watch batteries will last for each of the following intervals. So if I was doing 440 to 560, from 440 to 560, that's all within 1 standard deviation to the right, 1 standard deviation to the left. So based on this rule, 68% of my data should fall in there. So the way to find the exact amount of batteries is do 0.68, because that would be the percentage, and times it by the amount of batteries, which was 10,000. So this gave me 6,800 batteries would fall within that amount of days. So I do the same thing down here, 380, 620. That's within 2 standard deviations going both ways. And this would make it so 95% of my data should be in there. So I would be having 10,000 times 0.95, and that got me now 9,500 batteries. And then the other one that I went over with you was C, and this one's saying between 320 and 680. This would be within 3 standard deviations of both sides. So I would then have 10,000 times 0.997, and that would get me 9,970 batteries. So almost all the batteries, but you would have a few outliers still in there. So that's going to be the end of this video. I feel like that was a good stopping point because that was the last thing I showed you that had to deal with mostly just the standard deviation. and variance. So the next video is going to be solely about z-scores. So yeah, have a good rest of the day.